Which of the following gives the exact number of seconds in the last 6 complete weeks of 2007? Well, actually, that is the same as any 6 weeks. So in 6 weeks, well, in 1 week, there are 7 days. So it's going to be 6 times 7, 42 days in 6 weeks. And then in 1 day, there's 24 hours. So if I times the number of days by 24, I get the number of hours. And I just times by the number of minutes in an hour, and then the number of seconds in a minute. And that is the number of seconds in 6 weeks. And we want to write it using factorial. So 5 factorial, for example, is 5 times 4. We just kind of want to see if we can get all these numbers. Well, I've already got 6 and 7, so I'm going to leave them as they are. And I'm going to start breaking some of the other numbers down. So 6 times 7, I could do an 8 in there, and then I could times by 3. And then maybe I could times by, I want a 5, so let's go with that. It'd be 5 times 12, but maybe I'll write it as 4 times 3. So I've managed to get 6, 7, 8, 5, and I've got myself a 3 and a 3, so I've got myself 9. Oh, and I've got 4. And then for the final 60, well, I'll write this one as a product of prime factors, I think. So it would be 6 times 10, so 2 times 3 times 2 times 5. Yeah, let's write it like that. Okay, so starting from the beginning, we've got 2, we've got 3, we've also got 1, of course, we don't need to write that one. We've got 4, 5, 6, 7, 8. These two together give us 9. And then finally, that 2 times 5 can actually be 10. So that is 10 factorial. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. There are 10 factorial seconds in 6 weeks. Nice. Another way you could do this is how I did it. I think it's unnecessarily complicated, is we could break it all down into a product of prime factors. So I could write 6 as 2 times 3, and then times 7. 24 is 8 times 3, so that's 2 cubed times 3. Then 60, I've already got that, it's 2 squared times 3 times 5. And then I've got another one, 2 squared times 3 times 5. So now let's count how many 2's we've got. That's 4, 5, 6, 7, 8, 2 to the 8. And then let's do the 3's. So 1, 2, 3, 4, 3 to the 4. 5's I've got 1, 2. And then I've got a single 7. So I could now just start constructing it. I've got 2 times 3, and it's got to kind of keep tabs of this. And then for 4, I can write it as 2 squared, so I'm up to 3 lots of 2. And then 5, and then 2 times 3 for my 6. Put that in a bracket. And then it's going to be 7. So I've dealt with my 7. I just realized sorry, I didn't write 5 squared. Should have done that. Then 2 cubed. So I've now used 3, 4, 7 of them. And then 3 squared, and then 2 times 5. Okay, I can't go beyond that because I've now used, like I said, 3, 4, 7, 8. I've used all my 2's. It's just whether I've gone too far with any of the others. But I've got a 3, 3, and then that's another 2 3s, so that's 3 to the 4. And I can see I have used 2 5. So that's as far as I can get. I have used all the numbers, and I can see from this that it's 2 times 3 all the way up to 10, and hence it's 10 factorial. So just a different approach. It took a little bit longer, but not massively so. Both work pretty well.